hear me?
This meeting is being recorded.
Okay,
Okay.
you can start now.
Now we get started. Okay, so I haven't published the homework for the last time, but I will do it today. So today, let us continue what we were doing at the last lesson, but let us repeat doing this fact, running the simulation in probably the more effective way of simulation. So let me remind you the problem. There is a field. It could be a square field or a rectangular field, and two cells on the field are occupied. So one with the rabbit and one with the fox. Okay, and the dynamics is the following. The rabbit moves randomly to one of the how to say to one of the cells, so to right, up, down, or left, and the fox can do two moves. So if the fox steps on the rabbit, the game is over, and we suppose that okay, the fox ate the rabbit. If by chance the rabbit steps on the fox, then rabbit ate the fox. So rabbit goes first, fox goes next. Okay, and they start with some positions, top left and bottom right, or two random positions, random coordinates. So the problem is we are going to discover, first of all, what is the dependency of the time of the game from the size of the cell. Last lesson we started the simulation, drawing, animation. So let us continue doing this one more time here, but let us do it in a little bit, how to say, probably more supervised way. So it means I will be uh, so it will be great if it is still you who will be doing all this stuff, but I will give probably more supervision. So we are going to do the following. So first of all, we will be doing this in the more object-oriented way. This is the first thing. The second thing is that we will be recording all the trajectory. And the third is that after the trajectory is recorded, we will create the animation. Definitely, when recording the trajectory, we are not supposed to record all the field. So it will be just a sequence of steps. And for this sequence of steps, we have to record the position of the rabbit and the position of the fox. So we need one class that is called game trajectory, and that's it. And we need one more class, or maybe it's not a class and a function, just for visualization. So who want to volunteer? So uh, Daniel, Alexa, or Nina. So
I can,
okay, great.
if no one
So
wants.
that's great. Okay, so let's do this once again. So could you please share your screen? We could
Yes, of
either
course.
do programming in Google Colab or in your local Jupyter. Let's do it either way. Okay, great. That's Google Colab. So let's start from the beginning, or just open the new Colab.
No.
Mhm.
Uh,
Oh, yeah. Mhm. Good. So first of all, let's do the imports. Okay, that happens. What does it say? Okay, say new notebook.
okay.
Great. First of all, before doing anything, oh,
I will copy
yeah,
the
yeah, yeah,
impulse.
that's great. Okay, so let's name this notebook. So foxes and rabbits 2 or something like this. Or foxes and rabbits, I don't know, April 16th. Okay, great. Okay, so now let us write in the code. So let's create a class. So it will be class game trajectory.
I'll call it game.
Okay, game. That's great. Okay. Let us write the constructor. So def init, def underscore underscore init.
I
E,
can.
no, init initial. Oh yeah, if
I added the class fox and rabbit in the last code. So
oh no, and you
yes,
need
yes. I
partners.
I
No,
get
no, this will
yes.
not work.
Uh-huh.
So you need partners. Yes, good, great. So now,
But we need self in.
yes, exactly. Uh-huh.
And we want which attributes?
So we need to and in the game we also need not only self but the size of the field. So self n, yeah. Uh-huh. Great. And let's do the default value. So n equals to 5. I mean in the no, yes, here.
Like
No,
this?
no. Could you please turn on the lines? Uh,
Um,
yeah. Yes, here. Exactly. Very good.
I
So in
will add.
line 9, that's okay too.
Okay. Should I check this
Yes,
too
please
or
show it at good.
okay?
Yeah. And cell line 9 and here self say comma n equals to 5.
Okay, okay.
Yeah, and here
This.
okay, and there is a good practice. So in line 9, please do not use spaces between n and 5 because this is doesn't mean yeah, great. Okay, that's it. So now we need the rabbit position and we
Mm,
need the fox position. So let's create some random position. So okay, oh no, this will not work. So
Not random
random
or
round int. So we need to get the 2 coordinates. What does it mean 0n? Oh, but not too far. Yeah, okay.
I
Yeah,
think.
it should be np random. You didn't because you have imported numpy. So yeah.
And do we want it as tuple
No, it's great that let's
or
have it as
without?
a list. It should be a list,
Yes,
not a
yes.
tuple.
Okay,
hmm
as a list.
Okay, now let's initialize the rabbit also. And let's check that the rabbit is not at the position of the fox. So while self rabbit 0, no, not here. No, not here. Line 14. After, yeah, here, while. Great. Self fox 0 equals to self rabbit 0. And no, this will not work. This is a list. Maybe actually, I have no idea
I
whether it.
think it will. You can compare two lists.
Okay,
but you
yeah,
can.
yeah, that's good. While self fox equals to self rabbit. Not equals, equal.
Yes, yes.
Great. Okay, yes. Okay, great. So initialization is done. So now let's please create the method step. And this is self in the arguments.
Thank you.
Okay, do it yourself.
I will copy this.
Uh,
Or
let's do it in a little bit, how to say, more, maybe a better way. Let's go back. Uh, and let's define the directions. So the directions will be, say, directions. No, not here, 18. Yeah,
okay.
here. Directions. This is a list of lists.
Yes.
A
So
list. No, there's
no,
not a
no. Yes,
dictionary.
yeah,
It's a
I
list of
understand.
lists. 0, 1, 0, -1, or yeah. Okay, that works. Go ahead.
-1, 0.
Uh-huh. Okay, good. Now let's do fox direction, rabbit direction, or rabbit move. Rabbit direction, yes, equals to directions. Say directions. Open the, okay, and here it will be np random randint from 4.
Can I just say 4 or
Yeah, you can just say 4. Yeah, that's great. So now we have to do fox move 1 and fox move 2. No, rabbit does only one move. Only one move. So fox move 1 and fox move 2. Let's do fox move 1, not fox move. Fox move 1. Okay, great. Now let's move the rabbit. So
we can add the
yes, exactly. Self rabbit equals not here. Oh, what do you want? Already, yeah. So here self rabbit. Um,
no.
let's do the following. So when it is a list, let's do self rabbit. Mm, let's do a numpy array. Okay.
Okay.
Uh, oh no, not here. No, that's okay. So let's do it as a simple list. So self. Oh, this will not work. This will gives you the list of 4 elements. So you should say self rabbit 1, self rabbit 2, or 0. Yes. You need underscore
And
between rabbit and move in line 23. No. Oh yeah. Divided by n. Yes. Not divided by, yes. Modulo m. There
where
is
do
a
I need underscore?
in the line 23 when rabbit move. It should be rabbit underscore move. Yes, here. Okay. Let's do rabbit 1. Great. Now let us check that the rabbit is on the fox. If self rabbit equals to self fox.
What
Great.
does self stand for?
The
Self?
object of this class.
I
So,
see.
okay, so now we need two more things. We need the flag game over, and let's add it in the initializer. We need the iterations counter. Yes. No, it's not flagged. Please don't do this. Say game
Okay.
flag game over, and it should be self game over.
How do I do that?
Write down self
Self
game
game.
underscore over. Oh, it's better. Game over. Game underscore over. Great. Equals to false. Great. And self iteration also in the line 14. Yes, here. Self iteration. 0. And a self winner. There should be the winner. Who ate whom? Also self winner equals to none. Yeah. None. Okay, great. So if self rabbit equals to self fox.
I'll just translate it here.
Okay, yeah, great.
But
So now let's go here. Then self game over equals to true. Self winner is a fox. Or a rabbit, I'm sorry. The rabbit stepped on the fox. Okay, and we can do return because the step is over. Return.
I think we don't have to, right?
That's okay.
Yeah, yes.
This is just okay.
Yes,
And by the way, before after line 21, let's increase the step.
Increase the step.
Self dot iteration plus equals to 1. Okay, good. Go ahead.
Can I copy this for fox 1 and 2?
Exactly. And please check the game over in the same way.
The fox makes 2 steps, right?
Exactly.
And what if the fox steps on the rabbit on its first step?
Yes, it should be checked.
So the rabbit is also considered to be eaten in that case.
Of course, yes. Okay. Okay. Sounds very good. Okay. Now let us add the method for printing. So let us overload the how. Let me ask ChatGPT because I don't remember. How can I add the method for printing?
While Alexa is looking for the method, Daniel, why are you adding n everywhere before taking it modulo n? Is it some kind of type conversion?
Here.
Yeah.
Because we might have location over the field, so we add n and modulate. So if it moved in like here, move to 5. This is 5. Move to 6, 3. It will end up back here.
I understand, but you eventually take it modulo n, Why do it and before that? I mean, it doesn't mathematically. It doesn't.
If it goes other way, -1, we add n to
Wouldn't -1 modulo n be also somewhere inside the square?
minus.
again?
Well, -1 modulo 5, for instance, is equal to 4.
No. It will be not -5. It will be -1 plus 5.
Why? Wouldn't -1 in Python be equal to 4 modulo 5?
No, -1 modulo 5 will be equal to minus. Let me check actually. -1 modulo 5. Yes, -5 modulo 5 will equals to 4. Yes, that's correct. So
Also,
we may
But
not do it plus
we
n.
will always have positive numbers with this, and then modulate.
Yeah, not negative. Yeah. So actually we can not do in plus n, but let's keep it for the visibility of what we're doing. So we are on the donut field. Okay.
Okay.
okay,
Do
I
we
don't
have to
mind. I
change
just asked why do we need it? Because yeah.
Actually, we don't.
I thought that it was some kind
Uh,
of conversion because I'm not very familiar with Python, so I'm just asking some stupid questions.
we have
Sorry.
to have the convert this module because we compare these values. So if we have 6 and 1, it's actually
No,
the same.
the question was not about modulo n. The question was about adding n here inside the brackets.
Oh,
Yeah,
yes,
we
but
we might not doing this. Yeah.
Okay,
we
we
might
may
not
leave it
need
at
we might not need it.
okay. Please continue.
Just for okay. So now let us create the method for the serialization. So in line, yes, def underscore underscore str. Self. Okay, great. And here let us return the current situation. Return f. Yeah. Okay, great. Yes, yeah, great. No, not self s. Save. Oh, no. You may do it much simpler. Just print f.
Return
Lowercase
print.
f. No. Not return. F. Lowercase f. Return.
Okay.
Type return.
Return f.
F. Okay. No. Yes, great. And here say self dot. No, in the curly brackets.
Oh,
Yes, exactly. Self dot iteration equals iteration. Okay, that's it. Space. Okay, do the same as self dot rabbit equals
okay.
exactly. Oh, don't do the space. Okay, yeah, go ahead. Self fox equals. Okay, next. Self game over equals. Okay, great. Now let's do the test.
Is it double?
Yeah, this will work.
Okay.
No, this will do
This will
nothing.
not return nothing, but maybe
Yeah. Okay.
checks for.
Now we have just compiled it. So let's create another. Say shift plus. Yes, great. So game equals game lowercase equals game. Oh, capital, yes, uppercase game. Okay, and yes, great. So we have called the constructor. So now say while not game dot game over. Okay, game dot step. Oh, by the way, we have forgotten to add the trajectory. Oh, that's okay. Let's do it later. And let's print game. No, game step and then print game.
Game step.
Yeah, print game. Run it.
I have to first.
Not say not. Not. Okay, good. N is not defined. Where N is not defined? Of course, it should be self N. Say in the line 22, between 22 and 23. Okay, say N equals to self N. Okay, great. Compile it one more time. Run it. Okay, here you are. Does it make sense?
Yes.
Very good. So now let us add the trajectory
Do we
attribute.
want to print the winner too, or?
Only yes, let's print the winner. After everything, after point four, after 5, after line 4, yes. No, outside the while. Yes, here. Print game dot winner. I believe there should be a fox.
Rabbit
Oh, it's
in
rabbit.
the first
Interesting.
mode. But they started at the same position.
No, they did not start at the same position. This is the position after the
After,
game step.
yes, yes. Okay.
Let's run it one more time. Okay, fox. You see? Okay, very good. Now let us save the trajectory. So say self trajectory, it should be the empty array.
Would you
In
mind
yeah,
giving me just a second? I'm trying to follow along, but my Wi-Fi, but my laptop just shut down, so I have to get.
that's okay, that's okay. We will share this notebook definitely as soon as we are done.
Do you want to see the
Oh,
class or the running, the second part?
hello. Hello. Okay, let's go ahead. Let us add to the attribute trajectory and let's initialize it with the empty list. No, no, not here, not here. When we, yes, here, self trajectory.
Is this how we spell it, or?
Yes, exactly. And now let us create as the first element. They should be okay. Let's first element will be a rabbit, and the second element will be fox. So the element of this list is the dictionary. So let's create the dictionary. Exactly. So rabbit. Okay, in single quotes. Equals to self rabbit. Not equals, there should be comma. It's a dictionary. No, sorry,
No.
not comma, colon. Yes, great. Self rabbit, self rabbit.
And
Okay, great. And fox is self fox. Okay, and after the step, uh, the last step before return here. So say append. No, 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 not here. After all, game over. So game over means game over. Okay, so
before return or after?
yes, yes. After
Yes.
line, yes, here. So say append or self dot trajectory append. Append. And here we add the same dictionary. Yeah, this should be the same dictionary. You may copy paste from the top. So it should be rabbit, rabbit, fox, fox. Yes, this one. Exactly. But this should be not a list, but the dict. Okay, very good. Very good. Awesome. Let's go down and do not print the game. Let's do print game trajectory, but at the end of the game. Yes, here,
Okay,
but at the end
at
of
the
the game.
end.
Outside while. So, what is the meaning? What we are doing right now? So, game trajectory and game winner. So, awesome. Okay, it doesn't work.
I didn't run this code. We changed
Yeah.
some things. So
Good. Okay, yeah. Rabbit, fox,
can we do it?
in better way?
Yes,
Of
like
course.
print line, print.
No. Let's use pprint. So there's a special library. Let's in the imports from
Okay.
pprint import pprint. No, not here in the no. Please don't do import. Should be only in one place, upstairs. Yes, here. From pprint, double P.
Like
No. PP. Yes, go ahead. Print. And P should be lowercase. No, and another P also should be lowercase.
both P's are lowercase.
Exactly. Import pprint. Great. Let's go downstairs. Here and pprint game trajectory. And don't do game winner. Just pprint game trajectory. Let's try. Looks better.
Nice. Yes.
Okay, and at the end, so okay, great.
Why is the trajectory so strange? Why all the same?
Because this is a bug. Can you fix this bug?
Mm,
Do you understand? Do you see the problem?
we add
Oh no.
rabbits and fox
Let us
transitions at the
add
end.
game. Let us add print game between lines 4 and 5. So do you see the bug? So it looks like the trajectory is just one step, just one point.
Game something or
No, just print game. So we
but
have already
that will
stringified it.
return the object. Oh, okay.
What does this strange mean? 0, 4, and let us add winner. So who is the winner? One more.
Can I just
Yeah?
see line 16 again, please? I think it's 16.
16.
Okay, thank you.
So do you see the problem? It looks like the trajectory is just 1 point. 1 point.
Do we ever change it? Oh yes, we change it.
Of course we did. And you can see when we are printing the game step by step, we see the trajectory changes. You see 0, 3, 4, 3, 0, 3. So the rabbit is. Oh, by the way, let's print the winner. After line 8, say print game winner. Oh no, it should be game winner. Let us do not in this way, but let us do F curly bracket game winner equals. So it definitely a curly bracket game winner equals curly bracket closing curly bracket and double comma, double quote. Yes, great. Now you see what. Okay, you see game winner fox. Okay, So what's the problem? Can you fix it? Why it's not working? So it's working, but it shows something not good.
Well, I
Right.
don't know how dictionaries work.
Okay, that's
I
great.
think we need to add these brackets and
Please go ahead. The same.
or remove them.
Let's remove them. This will definitely not work, but let's try. Run it. So you didn't run. Okay. Dict object has no attribute append. So okay. So let me help you. The problem is that actually the self.rabbit and self.fox is not a list. So this is just the reference to the list. Like in C++, this is a pointer. Okay, so you're just copying the address in memory. So you are not copying the values. Does it make
Should
sense? There are several options how to do. Let's do the simplest. No.
Okay.
Let's do simpler. Let's do import copy in the imports. Good. And here, when you are initializing the trajectory, no, just in the initializing the trajectory. Okay, so instead of self rabbit, say copy dot deep copy self rabbit, line 17. Line 17. Okay, no, not here. Copy dot deep copy self rabbit.
Okay.
So you're copying the object. Deep copy. Yes, self rabbit. The same as for the fox. The same is when you are
But
updating
what
the
does
trajectory.
this do?
Because this will create the new object. This will create the new list.
Oh, okay.
And you are populating the trajectory with the new list, not with the reference with the existing one. Okay, let's do copy, deep copy, self rabbit. And copy, deep copy, fox. Okay, let's try one more time. Compile this part. Well, it's actually not a compiling. Oh, you see?
Yes, it changed. Okay.
Yes. Great. Okay, very good. Now, okay, actually we have two things, and let us have one thing from the whole for the homework. So for the homework, based on this notebook, please do the animation, the picture. Okay. And we now let us do the experiments. So what are our experiments? Our experiments is to figure out how long does it take to finish the game. Does that make sense?
Yes.
Okay, let's do it. So let's wrap uh, this part in the following. Let's call it experiment. No,
Well,
let's go down. So before line 1 in this, add some empty lines here. Okay,
comment.
yeah, that's great. Yeah, that works. That totally works.
Okay.
Okay. So let's create the experiment, and this should be the number. So the experiment will be just a list. Say experiments equals to list, empty list. Just empty list. And let us do the experiment. So let's create the variable number of experiments. Of experiments on one maybe field, for one field. So okay, number of experiments. Let it be 10. Let's start with 10. And let us create the field range. Field range. Okay, so this will be range, definitely. So let's start with 3 and let's sub with I don't know, 7. Okay, great. Now let's do 4 field in field range. Okay, 4 experiment in number of experiments. Experiment ID or experiment.
For experiment and range. No.
Yes, in range number of experiment. Okay. Oh, let's initialize it. Initialize the game. Game equals to the new game. Great. While not game over. Let's do game step. No, it's not a method.
It's
this is an
yes,
attribute.
attribute.
And game step is a method. Okay, and let's populate the experiments. So here after, so we know that it is game over. So here it should be experiments dot append. Okay, and we add the list here. So the list will so there should be field, the list. Square bracket.
Okay,
Yes,
okay.
the list field, and we need number of steps. How can we? How many iterations?
We can add a variable that counts it, or
It's already added.
as
It is iteration, so it should be game iteration.
game.
Dot iteration. Okay, run it. Okay, let's see what we have in experiments. Let's create the new cell. So this is important that okay, yes, here just print experiments. Pprint. You know this magic comment. Okay. Great. Can you plot this graph? So this is just some.
Yes, I.
Yeah. Great. You know how to do it. Let's do here.
Did I? Okay.
But what is X values, Y values?
That will be just I think it can plot like this because we have.
Let's try. Looks strange, right?
Yes.
Fix.
I can add we want to split the. Wait, let me just check how we can.
Okay, good. Go ahead.
We can do this.
Great.
This is also not good. Or is it?
Okay, that works.
What do we?
No, we
want?
don't.
Do we want average or?
Let's do anything with this result.
We can calculate the average number of
What is
iterations
better
for.
here, average or median? How do you think?
They will be the same for.
Let's calculate it. Oh, let's first of all remove this p print, because this p print it just spoils the screen. Okay. And let's do not plot, probably let's do scatter, because plot is creating the line, and you don't need the line. No, everything is good. Just no, remove. Okay, just instead of in the line 5, just instead of plot, type scatter. No, plt dot scatter. Plt.
Okay.
Yes. Okay, great. Run it. It will not work because y is not defined. No, go ahead. So the problem is in here, in the printing, in the plotting.
Did I?
Yes, you changed something. You should oh. Wait. Let's go back. Remove this.
Okay.
Okay, say Control Z. One more time. Several more times. So it disappeared. Okay. Let's do it one more time. Let's create the new yes here, and now let's plot it. Let's do it one more time.
Okay. Do I want to copy or do it myself?
That's okay. Oh, that's okay to copy, of course.
Okay.
Save it in. Yeah, great. Yeah, and here just say scatter. Okay, very good. Okay. Let's add 7 and 8 maybe.
This will.
Yeah, this will work.
Okay. So calculate the median or the average.
Both.
Okay.
And let's plot median with a red point and average with green.
Okay. Instead of this,
No, keep this. Let's
okay,
keep
okay.
as blue. So blue will represent the result of every experiment. And we will also have medians and averages.
Can I add the color here or
Please,
somehow?
of course. Yeah, color equals equal blue in yes, no, lowercase.
Okay, okay.
Let's try. I'm not sure that this will work, but let's try.
It works.
Yeah, good. By the way, please remove the spaces between equal side in color. So you see, do it in the same way as marker. Marker equals to O with no spaces.
So what should I do?
After the
Yeah.
word color, remove the space. You see the word color? No, color.
Oh, okay, okay.
Yeah, because this means that this is not the there's no variable color that equals to blue. This is
Yes,
just a
yes.
property. So just to distinguish this. Okay. So we need averages.
Just one question. What is
Yes.
the epsilon axis and what is the x-axis? Like, what does this graph represent? Like,
X
what are the
stands
axes?
for the length of the field, and Y stands for the number of iterations it takes to
That's
for
excellent
the
question. So let us fix the
Thanks.
labels, please. So you have the field
edge size. So what should I
field
label?
age size. Yes, field size.
Field size.
Great. And y-axis? To game over. Yeah. Do it one more time. Much better. And let's create a graph a little bit bigger because this is so small, so small. Before line 5, let's say PLT figure. FI, yeah, figure. Yeah. Okay, and here fig size. Maybe I don't remember. Fig size equals to, yes, fig size. There is a
Let's do 7, 7.
tuple. Let's do this. I believe it should be bigger. Oh,
7.
maybe not do 7, 7. Maybe do it 9 to 5. So, yeah.
That stands for the ratio.
No, that doesn't stand for the ratio. That stands for the width and height
Oh,
in
okay.
some values. It's not a ratio. Okay, looks good. So, do you understand what we need now? We need to plot the average. So there should be 5. There should be 6 red dots, averages, and 6 green dots, medians.
Oh, okay.
Go ahead.
I misspelled it.
Oh, but the averages should be calculated for every field size, not for
Oh,
total.
okay.
So total number doesn't give you anything. So please calculate
so I
it
need
for. Yes.
for
Very good. Just the average number doesn't give you anything.
Let me think.
Good. If you need help, please let me know. If you don't, go ahead.
Sure. We might speed up things, so.
Let us do it. Okay. So for item in experiments. So first of all, let us create the dictionary.
I think I can like this.
Item 1. What do you mean?
I can append the.
What is Y here?
We will make some smaller array that's. Oh, okay. I will do the dictionary.
Let's probably create the dictionary that we will call statistics. Y stat equals to dictionary. Y stat. Okay, yes, statistics. S, that will be dictionary. Oh, there should be, yes, okay. And there should be two keys. One key will be average and one key will be median. Yeah, but please no, average. Average is the key. And the value is an empty list.
Okay.
The same. Okay, great. Then median. And the value is also an empty list. Okay, great. So now let's fill this statistics dictionary with the actual averages and median. Okay, so let's do could you please show me? Okay, let's do for item in experiments. For item in experiments. Okay, great. So we need now to fill out okay, say in line 8, say, I don't know, x equals to, no, line 8, upper. X equals to empty dictionary. Great. So in line 10, say if item 0 not in x keys, x dot keys dot case, then x keys, this should be partners. Keys is a method. It's not the value. Keys. No, not here. X dot keys and two partners. Keys.
Okay. This or
yes.
okay,
I believe
okay.
this. Yes, great. Okay. Now say x square bracket item 0 equals to empty list. No.
Yeah.
Okay, great. So and then say go to the left a little bit. No, under if. Yeah, here. So x item 0 dot append item 1.
Like this.
No, not
or
here.
Okay, append.
Here, append item 1. Okay, great. So now we split all the experiments into brackets by the field. Okay, now let us create the values. So let's say x start. No, x underscore start equals to sorted x dot keys. Okay, great. So now let's do for the keys. So for x key in sorted x keys. Okay,
For
yeah, go ahead. It's okay, it's okay, it's okay, it's okay. For key in sorted x keys.
but we can.
Yeah, that's okay. That's okay.
That
Let's also
we can
create.
do x step, or because this is the same as.
Yes, yes, we can do this. Yeah, of course. In x stat. Okay, great. Let's calculate the average. So by the way, let us create y stat equals to, no, not here, under x stat. Y stat equals to empty list.
Okay.
Okay, very good. So now y stat, let's say not y stat, let it be y average. Not y stat, but y average. No, not here in line 15. Yeah. Why not stat? No, in line 15, still in line 15, not y stat, y avg.
Here in the.
Yes, here, not stat. Line 15 should be y average equals to empty list.
So before.
No, remove line
No,
16.
no.
Yes,
Why is
yes,
that
yes,
so?
exactly. Y avg. Okay, great. And y average. Exactly. And one more, y median
We
equals.
can. Okay.
No, no, let's keep it separate. Okay. That's great. That's great. Y dot average. Y underscore average. Append. So here we need sum of the list. Sum. No. Sum. There should be x key. Yeah. Sum x. Not
No.
x square bracket. Square bracket key divided by, and the sum should be divided
By length.
by length, exactly. X key. You forgot one curly bracket, so it should be sum x key and closing bracket. Not here, under the key, after the key, before len. Sum x.
Okay. This.
Yeah, great. And one now one closing bracket is okay. That's good. Let's draw it. Let's look at it. No. In the where scatter, so it should be one more PLT scatter.
Okay. I will just copy and.
Yeah, just copy. It should be X stat and Y average. Run.
There we go.
Good. Now let's add the legend to understand what is going on. In the line 23, let's slate label. Label equals experiment. No spaces.
Okay.
Very good. And here label equals average. Very good. After PLT grid, say plt.legend. Call the method. Great. Let's do it. Much better.
Okay. And
Okay. Now let's increase the experiments to ranges to 10. So there should be 11. The previous one. You see? So
a number.
I want to pay you attention. Let's keep it
Okay.
10. Run the upper cell. This cell.
Yeah, run it.
Already done. Okay. Okay, we see some strange situation. The bigger the field, the game doesn't change. What's the problem? So you understand, yeah? So
Yeah.
on the very big field,
Usually
it's
the
still
bigger field.
within 10. What's the problem? Can you find the bug?
I guess we didn't change self fan.
No.
We don't.
Yes.
We don't give it the
Great.
value.
N equals to field. No, not field. N equals to field. N equals field. Now let's do this. And it will be slow. Huh? Do you see the difference?
Yeah.
Good. So when you see something strange in your graph, this is probably a bug. So
What is the size of the board supposed to be up to 11?
No, 11 is the range. It means that 11 is not included.
Oh, I see.
Range 311 means
Yeah, okay,
3, 4,
okay.
5, 6, 7, 8, 9, 10.
I understand what semi-interval is, just don't know Python. Okay.
Yeah, so it's, how to say, one square bracket and one curly bracket. So it's not very convenient, but...
Semi-interval. Like
yeah,
polo-interval.
Polo-interval, да. Exactly. So, okay. So, let us increase it more to 20. 21. Okay. Okay. We still see a kind of an issue. For example, for the 19, there is definitely the outlier. So it was looking and looking and looking. So that's why the average is also not too good. Okay, guys, please share. So Daniel, could you please share your great notebook with everyone? It is
Yes,
absolutely
but
working.
where should I share it to?
To the
You can
Telegram
drop it
chat.
in the Telegram channel group, and I'll put it on the
Print. So
website.
there is a file expert IPython notebook. There must be. Not here. Not here. Download. So file download. Download IPNB. Huh?
Okay.
So
I'll
you have
send it.
just downloaded onto your computer. Okay, so there will be 2 homeworks. Not 2 homeworks. There will be 1 homework with 3 problems. So problem number 1. Add here the median value, average and median. Does that make sense? Median. So problem number 2. So actually task number 2. Given the trajectory of the experiment and the trajectory is saved, please create the animation. Does that make sense? Animation. Okay, and problem number 3. And problem number 3, let us do next time. So let us do, please do the 2 problems. Number 1 is the median value, and problem number 2 and the animation. And please see how stable, maybe problem number 2, this small. Please see the stability of the picture of number of experiments on one field size. Does make sense? Hello? Do you understand?
Yeah.
Yeah.
Good. So please do these 3 things. And then, so I hope that the next time, okay, bonus problem, actually, we will be doing this on next time. We need the value on some grid size that we definitely cannot achieve. For example, million to million cells. So we will be waiting forever until the fox will eat the rabbit or the rabbit will eat the fox. But we still want to know in how many steps this will happen. Does it make sense? It's a bonus problem.
Yes.
This is about the extrapolation procedure, and we will be doing it next time. But before, please get practiced with this. So one more time, median value and graph for this, animation, what's going on here, how they eat each other, and please see the stability. So here there is a number of experiments. There should be, I believe this is 10. So on each field sites we do 10 experiments, right?
Yeah.
There is one more thing that is still gives you a little bit of instability. The initialization of the field is 2 random numbers. So if there is a chance of rabbit and fox to be close to each other, then definitely the game is short. But if you put always, I don't know, rabbit in the center of the game, the field, and fox is to the side, so the variance of this graph will become smaller. But how to say, the essential homework is please do the median research. Average and median. Median is very important. Does that make sense?
Yes.
Okay, so please, and probably see you in a week. So, and we will be also working with this game. Okay, so, and please share the notebook. So yeah, and please see how important it is to write the program in the OOP way with classes, so you can distinguish everything. It's modular. It's not functions. It's classes. Classes are good. Use classes. They are simple. They are for help. Okay. So see you in a week. Hopefully the same time. Okay.
Okay.
So see you.
Okay, thank you everyone for joining. Thank you, Alexei. I hope you enjoyed this, and we'll be waiting for your homework. Bye bye, everyone.
Can someone just add me to Telegram group, since I was just able to make an account.
Yes, can you write me your phone number or something, or find me, or find one of the guys or Nina?
I can send you right now in the chat.
Yes, please.
Okay. Thank you so much.
Okay, see you all in a week. Bye bye.
See you.
See you. Goodbye.
Here, I post this one.